My esteemed viewers, this is Dr. J Physics Lecture Series. So we'll be looking at heating effects of electric current. Heating effects of electric current. The focus here will be on Joule's law. What is Joule's law? Well, before I state the law, let me write the equation expressing Joule's law. H is equal to I squared RT. Once you remember this expression, then it's much easier for you to state the law using that equation. So you can state the law as the quantity of heat produced in a metallic conductor, H represents heat. So the quantity of heat produced in a metallic conductor is proportional to the resistance, the square of the current, and the time for which it flows. So let me give the expression. Joule's law states that don't mind the writing. Joule's law states that the quantity of heat produced in a metallic conductor is directly proportional to its resistance the square of the current and the time for which it flows. Now, this equation has different variants. We can express that equation in another form. If we recall from Ohm's law that V is equal to IR, therefore our arrow will be equal to V over I. We can decide to replace arrow with V over I. So we say that H is equal to I squared. Instead, in place of arrow, we use V over I times T. So that this gives us IVT. That's the variance. Also, we can say that I is equal to V over arrow. So in place of I, we say H is equal to, here we have I squared, we replace it with V over arrow or squared times arrow times T. If we do that, our H will be equal to V squared over arrow squared times arrow times T. And that leaves us with V squared over arrow T. So anyway, we can express H like this. We can express H as equal to IVT, and we can express H as this. So whatever parameter that you are given, you can actually use it to find the value of H, as the case may be. So I'm taking this off to pave way for another section. So let us look at power. So the rate at which energy is converted to heat is defined as power. Mathematically, we can say power is equal to IV. There are other variants. Just recall that I is what? V over R. Replace it into that equation so that P will be equal to V over R times V. That equals to V squared over R. Or we can also say that V is equal to IR. If V is IR, then P will be equal to I into IR, which is equal to what? I squared R. The unit for power is the watts. And the watt is defined as the rate of energy usage in 1 joule per second. The rate of energy usage in 1 joule per second. You have 1 kilowatt, which is equivalent to 10 raised to power 3 watts. We have the megawatts, so 1 megawatt, which is equivalent to 10 raised to power 6 watts. So let us look at a few examples and we wrap it up. So assuming we have a problem, we have a problem in the sense that an electric ion is rated 1000 watts, 230 volts. What is the resistance? This is quite easy. Your power is given as 1000 watts. V is equal to 230 volts. You are asked to find R. Now, I always say this is the simplest equation for power. But we don't need current. We don't have current. We are looking for R. So once you can remember this expression, you can get any other one from it. We know that I is what? V over R. So if we resubstitute that, put this into this, then our P will be equal to V over R bracket V, which is what? V squared over R. So from that equation, our arrow, since P is V squared over R, that implies that our arrow will be equal to what? V squared over P. So you use your calculator to do the maths. 230 volts all squared all over the power P, which is 1000 watts. Eventually your resistance arrow will give you 52.9 ohm. So once you come across any equation that has to do like this, any equation, any question expressed in this format, you know the exact equations to apply. I have another question that tells you that when connected to a mains of 250 volts, so this is 250, the fuse rating in the plug of an electric device is 1 kilowatt. So our P is 1 kilowatt. And 1 kilowatt is equivalent to 10 raised to power 3 watts. So this is 10 raised to power 3 watts, which is 1000 watts. You are asked to find the fuse rating. So we are looking for the current I. Again, we say P is what? IV. I will be equal to what? P over V. P is 1000. 1000 watts. V is 250 volts. So that tells us that our current is what? 4 ampere. So coming across questions of this form can be easily answered with either of the equations. So there's not much to handle here because most of the questions are very similar. So we could end here. So once again, when you are studying problems of this nature, first of all, bring out the parameters. When you get the parameters in the question, it helps you to identify what equation to use. Like in the case of this particular one, once you can remember this equation, P is equal to IV, you can get any variant from this one. Just remembering that from Ohm's law, V is what? I, R. And that helps you to get any other variant you wish to get to solve your problem. So once again, I want to thank you for listening to my lecture. If there are improvements that you want to suggest, you can use the comment section to suggest the improvements. And if there are any errors you noticed, you can also draw my attention to such in the comment section. I remain your one and only Dr. J. God bless you. Have a nice time.